All right, here we go. I am going to set x equal to 2 sine u because I want to get this 2 to match up when I square it with the number in front, so that when I factor out, I end up with something that looks like 1 minus sine squared. And then I can create the trig identity relationship and change it to a cosine. So I'm going to take the derivative, 2 cosine u du. All right, so I substitute all of this into the integral, and I get 4 minus 4 sine squared u. And then in place of the dx, I put this whole thing. Now I can factor out a 4. And then I can take the square root of the 4, which is 2. And then I'm going to take both these 2's and put it out front. And I am left with the square root of 1 minus sine squared u cosine u du. Okay. 1 minus sine squared is just cosine squared, and cosine squared with the square root results in just this whole thing becoming a cosine u. Combine a couple steps there, so take your time and think about what I just did. And we are at this point in the problem. All right, so now we have to use that trick from the homework. There's another way to do this, but it involves a trig relationship that you probably don't know, and I'm not going to go into that one because that's another thing you have to remember. Instead, I'll take this opportunity to review integration by parts. So I'm going to do this problem using integration by parts. So remember, we are looking for the solution of this. I want to know what this thing equals. Okay, so in order to do that, we're going to rewrite it. And really, I'm focused on this part right now. I'm going to rewrite this as the integral of cosine u times cosine u du. Integration by parts. We already have a u in the problem, so sometimes it makes sense to use w's instead. So I'll use w in dv. dv is cosine u du. It's always the back one. And then v, or w, is going to be the front one. dw, take the derivative of that, negative sine u du. V is the antiderivative of cosine u, which is sine u. Put them together. So it's telling me that this integral is equal to wv, the first two, the top two of the 7, cosine u, sine u, minus, but since there's already a minus, it's going to be a plus, sine squared u du. I'm going to use a little identity right here to get 1 minus cosine squared u du. Oh, there's not a plus there. Sorry. All right, so this is where we're at in the problem. And remember what my goal was? It was to find that green box. So I'm going to set this equal to that green box. And then the cool little strategy comes in where if I rewrite this, plus I'm going to split up the integral. 1 du minus integral cosine squared u du. Well, here's the piece I want and what I want it equal to, so I'm going to add it over to the other side. And I'm going to take the antiderivative of 1 with respect to u, which is u. And then I'm going to divide by 2. So look what I have. That green box that I was looking for up there equals this. So I am going to substitute that in right here. I'm running out of room, so I'm going to scoot over a little bit. Substitute it in over here. cosine u sine u plus u divided by 2. And we have gotten to this point. 2 cosine u sine u plus 2u. Okay, I distributed the 2 after I reduced everything. Now comes the last part. Go back and use our what x and u relationship. Oops, what did I just do? X is equal to 2 sine u. So we'll rewrite that real quick. Which means u is equal to arc sine x over 2. And we plug everything in. Well, first, before we make it worse for ourselves, look at this. 2 sine u, I can rewrite that as x. Cosine u, I'm going to have to do it as cosine of arc sine x over 2. And then plus 2u, which is arc sine x over 2. All right, now we do the little triangle trick and we're almost there. Triangle trick says if that's theta, sine is opposite over hypotenuse, which means this is 4 minus x squared. Square the hypotenuse minus the side squared. So the cosine of that is equal to adjacent over hypotenuse. And finally, we can substitute this back in for this whole portion right here. So it's x rad 4 minus x squared over 2 plus 2 arc sine x over 2. Done. Pretty awful, I know. I'm not going to feature a ton of these problems this year, but I want you to see, if you plan on taking higher levels of calculus, multivariable calculus, this is the type of stuff you do on the regular. You have to invoke various integration strategies, and this one had a lot. Like I said, we could have saved some time here using the angle or the power reducing formula, but I didn't want to incorporate something new that you probably don't remember. So we went back and did integration by parts, did a cool little trick here where we added the thing we were looking for to the other side, and then you had to remember the trig at the end here with the little triangle. That's it. So that was 7.5 minutes. I am going to check the answer. So if you're curious how, because if you notice, like, how does the antiderivative of this look like such a monstrosity? There's no way this was going to equal that. I am going to check my answer. So if you want to watch this part, you can. You don't have to check it. I always like to go through this just to make sure it works. So I'm going to check the answer. If I lose myself halfway through, I might just stop. But let's check the answer and see how it does. So I'm going to rewrite this as x over 2 radical 4 minus x squared plus 2 arc sine x over 2. All right, so this is a product rule. Derivative of the first times the second plus derivative of the second times the first and then plus 2 over the arc sine, or the derivative of the arc sine, and then times the derivative of that, so times 1/2. Okay, how am I going to get all this to look nice? Well, first thing, I'm going to rewrite this as a fraction with the 2 on the bottom. I'm going to put my minus here, that minus. I'm going to put the 2x squared up top, and it looks like I have a 4 rad 4 minus x squared on the bottom, plus, I'm actually not going to cancel these 2's for a reason I'm going to get into in a second. I'm going to keep the 2 up top. I'm going to keep the 2 on the bottom. If I can get common denominators, I can combine all these together. So I am going to cancel these ones. So we're left with just a 2 here. This first fraction needs a radical 4 minus x squared in the bottom. So I'm going to multiply by 4 minus x squared, rad 4 minus x squared. Well, the cool thing about the top is it just becomes 4 minus x squared over 2 rad 4 minus x squared. This one's already done, so I'm just going to rewrite it. minus x squared over 2 rad 4 minus x squared. Now this one, I'm actually going to end up putting the 2 back inside, which means it becomes a 4. It's kind of the reverse of the very first thing we did, or one of the first things we did. So really, I'm putting it back in, and I'm going to multiply both things by 4 inside. So it becomes radical 4 minus, and then this is x squared over 4 times 4, so just x squared. So the only other thing is it needs a 2, because I took the 2 that was there and put it inside, but there still needs to be another 2, so I'm going to multiply top and bottom by 2. All right, so now I am going to simplify this into one fraction. 4 minus x squared plus 4 is 8. 8 minus 2x squared all over 2 rad 4 minus x squared. 2's cancel, so I can turn this into a 4 and this into this. So I end up with a 4 minus x squared up top over radical 4 minus x squared. Finally, I'm going to rationalize the denominator by multiplying by the denominator. Well, what that does is we end up with a 4 minus x squared times rad 4 minus x squared up top all over 4 minus x squared on the bottom. And lo and behold, we end up with rad 4 minus x squared. Okay, algebra, very algebra heavy. That check is probably almost, well, it's not harder than the problem, but that's a lot of stuff going on there. Okay, so 12 minutes to do a problem and check it. It's not too shabby. We will not do a ton of these this year, so don't cry at me about how hard they are. But we are going to pop them up here and there. This one was on the harder side. The last one we done, the last one was easier. This one was a little bit harder. But I have to show you guys some of these things because these are out there and they're really a part of this course. But the AP test doesn't emphasize this, so I don't either too much. All right, that's it.